Let's find the horizontal asymptotes for this rational function. Again, to find horizontal asymptotes, we take a limit of our function as x approaches infinity and negative infinity. And if we have a polynomial numerator and a polynomial denominator, a very common way to do this is just to divide both the numerator and the denominator by x to the highest power in the problem. When we do that, we get some simplification, which is great because now we can take our limit as x approaches infinity quite easily. You'll notice that the numerator just turns into negative 4 plus 0 minus 0, and the denominator turns into 4 plus 0. That gives us negative 4 over 4, which is negative 1. Now, does that make sense? As x gets really, really big, this first term in the numerator will dominate, this leading term here. That'll dominate the numerator. This 4x squared, this leading term in the denominator, will dominate the denominator. So we should expect, as x gets really big, for this function to behave just like negative 4x squared over 4x squared, which would then reduce to negative 1. Now, if we think through this, the limit as x approaches negative infinity is going to be exactly the same. You'll notice that the same terms dominate, and the reduction all happens exactly the same, and we get negative 1 as our limit. That gives us our horizontal asymptote of y equals negative 1. Now, as far as vertical asymptotes are concerned, those occur when the limit as x approaches some number of our function goes to plus and minus infinity. Now, just as a reminder, there's the function right there. And perhaps we could factor the numerator, but we're not really able to factor the denominator, and things aren't going to cancel. So the question you might be asking in your head right now is, when is the denominator going to be equal to 0? Well, as it turns out, the denominator is always positive, at least for all real x values. If you square that x value, you get a positive number. You multiply it by 4, you still get a positive number. And if you add 2 to it, you still have a positive number. That can never equal 0. Now, you could actually try to solve this equation. You would get x squared equals negative 1/2, and you'd be running into imaginary numbers here. Since imaginary numbers don't really show up in our graphs of functions, we do not have any vertical asymptotes for this function. Okay, and that's going to do it for that problem.